Hey, grade nines. So in today's lesson, we're going to go over the equation and the slope of a line. So this is our last lesson of this unit, but I just want to make something really clear before we start. Obviously, there's going to be a lot of content in this lesson because we're basically summarizing all the big ideas that we talked about so far. But just keep in mind that for your quiz today, it should be relatively easy. It's just focused on, I'm really just focused on kind of the basic concepts that we talked about so far. So if you can identify slope, identify y-intercept, find the equation of a line, we're going to talk about that, and basically identify if it's linear or nonlinear. That's the main thing that we're kind of focused on, right? And of course, we talked about the first day linear pattern. So just make sure you go over that. But of course, I still want you to go through this lesson fully because a lot of these concepts that we talk about in Unit 3 will carry on in Unit 4 and 5. So we're not done with it yet. So even though this unit is ending, just keep in mind that Unit 3, 4, and 5 are kind of intermixed. They do have a lot of overlap. It's actually really hard to differentiate between them. Unit 4 tends to be a little different, but you'll notice that Unit 3 and Unit 5 will seem extremely similar. And you'll actually notice here in the textbook, we kind of fly over to chapter 5. So just the fact that we're going between Unit 3 and Unit 5 kind of tells you how interconnected they are. So definitely make sure that you go through this entire lesson fully. Listen to the video, go through the examples, and make sure you really understand it because this will carry on in the future units as well. All right, let's get started. So quick little overview. We talked about slope and y-intercept, and I feel like I probably mentioned it a bunch of different times. So the fact that I'm mentioning slope and y-intercept over and over again probably should tell you that this is important, right? These are not little concepts that you might forget. If there's anything from grade 9, I always tell all my students, remember slope, okay? We talk about it a lot in grade 9, and this concept continues all the way up to Unit 6. And technically, it continues all the way throughout the whole entire course. So definitely make sure you understand that. So slope is basically measuring how fast or how slow a line moves. And we've actually talked about a couple ways that we can measure it. The most common one is rise or run. So you essentially pick 2 points on your line, any 2 points on the line, and then you calculate how much it's going up by vertically, and then you divide by how much it's going across by horizontally. So it's the vertical change divided by the horizontal change, right? And then an easy way of saying that is just rise over run. So that's really what we're doing. We're just trying to calculate the vertical change and divide that by the horizontal change. The y-intercept is where the graph hits the y-axis. And so that's when x is equal to 0. So pretty easy definition there. So what is the slope and what's the y-intercept in this case? Well, to find the slope, let's start with that one first. Actually, let's start with the y-intercept. The y-intercept is probably the easiest. So we can actually clearly identify here that the line hits the y-axis at -3. Now, I just want to be clear because some of you maybe had this question before for me, so I just want to clarify it. When we talk about the x-axis, we are talking about, sorry, when we talk about the x-coordinates, we're talking about the numbers that go along the horizontal axis here, and the y goes vertical, okay? So when we're finding the y-intercept, we're trying to figure out when does it hit the y-axis, which is right here. So it hits the y-axis at -3. So our y-intercept is, and when we write this in coordinates, it's going to be 0 and -3. So notice that the y-intercept will always have an x-coordinate of 0. So because the x-coordinate is always 0, it's almost not relevant in terms of the equation. And we'll talk a little bit about the equation of the line. We haven't discussed that yet, but you'll always notice that the y-intercept has an x-coordinate of 0. And sorry, the y-intercept has an x-coordinate of 0. Just want to make sure I said that right. And then the x-coordinate, the x-intercept, we haven't talked about that. We're not talking about it in this unit, but I know we've covered that before. The x-intercept is when the y-coordinate is equal to 0. So for the y-intercept, the x-coordinate is always equal to 0. Okay, so just want to make sure everyone's clear on that. So how do we calculate slope? Well, to calculate slope, you just pick 2 points on your line, and then you calculate the rise and the run. Now, I already have one of my points, so this is pretty easy, 0 and -3. And generally speaking, what you want to do is you want to pick another point on the line that's easy to read. The y-intercept tends to be relatively easy. Maybe pick another point. So I'm just going to pick randomly. I could pick this one here, or I could pick this one right here. We might as well pick the one that's closest, right? So I'm going to pick this point here, and I'm going to get what coordinate is this? It's going to be 1 and -1. So just keep in mind, I could have picked 2 and 1, but I honestly just picked 1 and -1 just because it's closer. That's all it is. So what I'm going to do now is I'm going to calculate what the rise is. So how much is it going up by? So we can see here it's going from -3 to -1. So from -3 to -1, we can see it's going up by 2. And how much is it going across by? So it's going across by 1 because it went from, in the x coordinates, from 0 to 1. So I can see here it's going up by 1. Sorry, going across by 1, not up. So then to calculate the slope, all I have to do is calculate rise over run. So I can see here that my rise is going up by 2, and my run, it's going across. And I think I mentioned this already. Normally, when we talk about the run, I would recommend just going left to right when you view this. And we'll talk a little bit about positive negative slope. So I can see here the run is 1. So it's going to be 2 over 1, or 2 divided by 1, and 2 divided by 1 is 2. So keep in mind, I could have picked these 2 and 1 as well, along with 0 and -3. And if I had done that, and we can just do the math here, let's just erase this so I can see it a bit more clearly. So if I were to pick these 2 points, so 0, I'm just going to write these down again so you can see it. So 0 and -3 and 1 and 2. And let's say calculate the rise over run. Oops, whoa. That was a little off. So I can see here that my rise is 4. Just want to show you get the same answer. And my run going across would be 2. So that means that my rise over run would simply be 4 over 2, and 4 over 2 obviously gives you 2 as well. So notice that you get the same answer regardless of the points that you pick, right? And that's the idea here. I could have picked this point up here. So I could have picked, so what point would that be? That would be 4 and 5. I could have picked, there's actually multiple options here. I could have picked -1 and -5, many different choices. But you ideally want to pick points that are easy to read, right? You don't want to pick, as an example, don't pick this one over here, because this is really, you're almost going to second guess this, right? Because if it's in between the actual lines here, then you're not exactly sure where it is. So always pick points that are relatively easy to read. So obviously our slope is 2. So how do you find the equation of a line? So this is actually not too bad, and we've actually started talking about this in the last lesson. We kind of, sorry, not in the last lesson, lesson 2, we kind of introduced this a little bit. So first thing, I think you might have noticed that all the linear relations have a form that looks like this. It has y is equal to, so all of them start with y is equal to, and then there is a coefficient in front of x. Not always, but the majority of the time there's a coefficient in front of x, right? And then we noticed that a lot of times you had a number that was added at the end. Sometimes there wasn't a number added at the end, and we'll talk a little bit about that. If the number isn't added at the end, then that means that the y-intercept is 0, right? And that's actually an example of direct variation. So keep in mind that sometimes there isn't a number at the end, and that would mean that the b is equal to 0, right? You're basically just adding 0, which means nothing's happening there. So we notice that linear relations always have this form, right? So it's y is equal to some number, which is our slope in this case, multiplied by the variable x, and then we add a constant at the end. So what do each of these mean? Well, I talked about the first one. M is slope. And this is actually what we figured out when we did that activity on slope and y-intercept. That's actually why I wanted you to focus solely on that in that activity, because of how important slope and y-intercept is. So slope is essentially just measuring how fast or how slow the line is moving, and how basically it's telling you how much the y increases by relative to the x. That's really what it's saying there. And then the b value, which is the constant at the end of the equation, is your y-intercept. And your y-intercept, we already talked about it, is where the line hits the y-axis, right? And then when we talk about word problems, we'll get to that near the end. That's normally kind of your starting point, or where your relation starts. You can think of it that way. So x and y, I want to make this clear because sometimes people are a little confused by this. They think they have to sub something into x and y. those are variables, right? So when we do look at word problems, we will eventually substitute values into them. But generally speaking, when we find the equation, we're not actually replacing x and y. X and y are the variables. Those are the ones that are going to be changing throughout, right? Depending on the question. So x is the value that we are subbing into our equation, right? And this is our independent variable. So if you kind of go back to when we talked about independent versus dependent, this x variable is our independent one. This is what we sub into the equation, and you choose that, right? You generally get to choose what x value you're going to sub in, and then the y is going to be whatever your answer is at the end. And this is your dependent variable, because obviously the answer depends on the value for y depends on what you sub in for x, right? So x is what you sub in, and then y is what your result is. So you almost want to think of this as if it's like a little machine, right? We have x, we sub it into this equation, and then this equation is basically like a giant computer. Think of it this way, right? So we take our x value, sub it into our computer here, and then it shoots out the final answer, which is our y value, right? So that's essentially the best way to think of this, right? X is our independent, that's what we sub in. Our y is our result, right? And so those are the two variables you have there. So a point x and y, it's going to satisfy the equation, and this is more of a point that we talk about later on. If when you sub in x and y, let's say that you want to check is a point given to you on the line or not. So what you want to do is sub in the point x and y, and you check if the left side equals the right side. If the left side equals the right side, then you know that it's on the line. So in the last example, kind of connecting this all together, we noticed that the slope was 2 and the y-intercept was -3. So our equation, all we need to do is kind of piece this together. We know that the slope, the m value, is going to be 2, and the b value right here at the very end is going to be my y-intercept. Now, I believe I wrote down the y-intercept in coordinates, right? I wrote it as 0 and -3, and this is absolutely correct. But when we actually sub it into the equation, we don't write it like this. This actually doesn't really make sense. You would never add a coordinate like this. That really doesn't mean much, right? So what we do is we basically just sub in the y coordinate, because the x coordinate is kind of a moot point because we know that it's always going to be 0 for the y-intercept. So all we do is simply sub in -3. So our equation is y is equal to 2x, and 2 is coming from the slope, and -3 because that's the y-intercept. I hope that kind of makes sense. So let's now we're going to talk about steepness of a line. And of course, this equation of a line, we'll revisit it, so we're not done yet, okay? I just want to go through all the main concepts, and then we'll talk about how to find the equation of a line. We'll do more examples, okay? So steepness of a line. So there's different levels, different types of slopes that we can have. So we've slightly discussed this, but we haven't gotten into the details yet. You probably have noticed that most of the examples I've done, I did this on purpose just to not throw you off too much. Most of our examples have dealt with positive slope, and that generally means that your line is going up to the right. So we read graphs the way you read a book, right? So we know, or the way you read writing, right? You're actually reading this right now, left to right. So that's actually the exact same way that we read a graph. We always go left to right in this case, right? So if you're going left to right, and obviously this is in the Western world, right? Other countries, they actually read the opposite direction. But generally speaking, when, like I said, right now in North America, obviously, we read left to right, and that's the way that we read the graph as well, okay? So if you're going left to right and you notice that the graph is pointing up, then that means it's going to be positive. And then if you see that the graph is pointing down to the right, so as you go left to right, it's pointing down, then you know it's going to be negative. So this is the direction that you're looking at to determine whether it's positive or negative slope. And this is extremely helpful because a lot of times this is an error where this is where a lot of people make an error. It's very easy to make a mistake with the signs. It's very easy to mix around the coordinates. I have done it before. It's super easy to make that error, right? But if you just remember the rule that if the line is going up to the right, it's positive. If the line is going down to the right, it's negative. Then it's a great way to verify that the answer is correct, okay? And again, I think I said this already, use decimals to your advantage, right? Use grid, definitely graph all the points. So if I ever give you 2 points, I would definitely suggest drawing the 2 points on a grid and then just draw a line going through them, and then you can quickly tell me whether it's positive or negative, right? So if the 2 points are like right here as an example, I'm just going to do a different line with a different color here. If those are your 2 points and you draw a line through them, you obviously know the slope will be negative because it's going down to the right. So that's what I mean by just doing a quick little check there. So steepness, we talk about steepness a lot. Steepness is kind of another way to describe slope, right? So there's two things when you're looking at slope. Is it positive or is it negative? And then you're also looking at, is it steep or is it not steep, right? Is it less steep or more steep? So steepness is basically, if any of you have ever gone skiing, um, steepness is basically measuring how fast that hill is going, right? So if you say it's a steep slope, then obviously it's going to be a little bit tougher, right? So this right here is obviously going to be tougher than a hill that's like that. So you can obviously see here that if you're skiing on this, this is going to go slower, right? Because it's not as steep. Whereas this one is a much more steep. It's a bigger slope. So it's obviously going to it's going to go faster. So when you're looking at steepness, it actually doesn't, you don't actually care about the direction, right? So if I were asking you about the steepness of this slope here, it doesn't actually matter that it's going down to the right. Because if you look at this, both slopes technically are negative, right? Because it's going down to the right. So both of these are technically negative. But just because this is negative doesn't mean that it's a small slope. So when you're looking at this, you're actually trying to measure magnitude. So you're not worried about the sign at all. You're just looking at how big. So magnitude, I don't know if you ever heard that word before. It's basically how large the number is. It's how large the number is regardless of the sign. Okay, so what I mean by that, and this is a perfect example, if you look at the slope, this equation here, we have y is equal to negative 4x, and then we're comparing it to y is equal to 2x. Well, you can see here that negative 4 is a slope, right? Because that's the coefficient of x. And negative 4 is technically smaller than 2, right? I think everyone can see that negative 4 is smaller than positive 2 on the number line. But when we're looking at steepness, negative 4 is still more steep than positive 2, right? Because you want to think about how steep, like how that line looks on a graph, right? And I can actually probably show you this on Desmos just so you can kind of compare it. So if I have the line here, y is equal to negative 4x, and I want to compare it to y is equal to 2x, I can see here that the red line, which is y is equal to 4x, this one right here, is obviously, if you're skiing down, think about it this way. If you're going down the hill, which one is, if you're skiing, which hill is tougher? So obviously this one, even though it's a negative slope, you can see here it's more steep, so it's going to be tougher there, right? So that's a more steep hill compared to the blue one, which has a slope of only 2. Okay, so when we're looking at slope, we basically compare them. If you're looking at which one is steeper, you're comparing the slopes without looking at the signs. And whichever one is a bigger number without the sign, that is going to be your steeper line. Keep this in mind because I will actually be asking you a question about this on the quiz. So little hint there, okay? So that's definitely going to come up. All right, so now let's look at horizontal lines. So the first thing I'm going to ask you is to plot this point. So the ones watching the video, I'm going to assume that you're going to pause this and you're going to do it yourself, or time's up. Here's a graph. For everyone else in the class, we're going to do this together. So for the ones that are watching the video, hopefully you stopped it and actually plotted it out. It's good. It's a good little review just to go over how to plot points. So -2 and 4 is obviously up here. 1 and 4 is up here, and 5 and 4 is up here. And again, a reminder, friendly little reminder here. You always plot out the X and then you plot out the Y, okay? So once you have the 3 points, you're just gonna take a straight line and draw going through all 3 points there. So we can see here that we get a nice little horizontal line. The title kind of says it itself. I kind of wrecked it there. So it's obviously horizontal lines that we're looking at here. So what do they all have in common? Well, they all have the same y coordinate, right? I can see here very clearly that the y coordinate for all of them is 4. And because of this, we notice that there actually there's a special equation that we can use for all these type of examples. The y-intercept, I'm going to talk a little bit about the equation, but just one small thing. The y-intercept we can kind of see here is simply going to be the only part that really matters in terms of our equation, right? The y-intercept is basically where it crosses the y-axis, and this actually makes it really easy because there's only one y coordinate the whole way through. And a really important thing, you might notice that the slope is 0. It doesn't change at all, right? So if I asked you about slope, I know we talked about being positive or negative, and there was an option I did not mention. The slope could also be 0. So if the slope is 0, what that means is if you're picturing again, picture the skiing example. If you have a hill and it's just a straight line like this the whole way through, what does that mean? That means you're probably skiing, but you're probably doing something else. You're probably cross-country skiing, right? So if someone's skiing here, that's not a very fun hill to be skiing on, quote unquote, because you're not really going up or down a hill, right? You're just going straight. So that's what this really means, is if you have a slope of 0, it means you're not moving at all. So no change, right? So horizontal lines have a slope of 0, okay? And what I mean by the equation, so I'll go back to this part. What I mean by this equation of y is equal to b is I'm saying all you have to do is identify what the y-intercept is, which in this case is 4. And because the equation in this case, it's almost a bit strange because there is no slope, right? So technically, because there's no slope, you can almost think of it this way. Instead of having y is equal to mx plus b, our m right here is 0, so you're gonna basically sub in 0, and then our y-intercept is 4. But because you have 0x, it's basically just nothing. So then we end up with something really easy. We end up with just y is equal to 4. So the best way to remember this is that with horizontal lines, all you need to do is simply write down y is equal to whatever the y coordinate is that it goes through, right? So we're essentially saying if we're trying to identify this whole entire line, if somebody asks us to describe it, how would you describe this line? You basically are saying, well, all the y coordinates are equal to 4. So we simply write it as y is equal to 4. And if I had, just to give you a different example, just so you practice with this, if I were to give you a line like this, and I said, okay, give me the equation of that blue line right here. Well, it would simply be y is equal to -3. I'm essentially just saying the line that describes it is y is equal to -3 because the y coordinate is always equal to -3, regardless of what you sub in, right? Doesn't matter what x coordinate I sub in, my y coordinate is always -3. And so I read it as y is equal to -3. Vertical lines. So for this one here, I'm going to ask you to plot these points. So I'm going to give you some time, obviously in class. And if you're not in class, you're watching at home, time's up. Here's a graph, right? So I'm obviously going to notice that this, again, when I create a line going through it, it forms a vertical line, and the title kind of says it itself. And so these, obviously, what do they all have in common? Well, we notice that the x coordinate is all the same. So we look at their x coordinates. They're all equal to 3. So I don't know if anyone wants to take a guess. Maybe the people watching a video, I don't know if you want to try this. What do you think the equation would be? It's a little different. This one really tends to throw people off because it's completely different from everything else. But I think some of you might be able to guess what it is. So they all have a form of x is equal to whatever the x coordinate is that it passes through. And the reason there's no y, people always ask, well, what about the y is equal to mx plus b? The vertical lines basically break all the rules, right? This doesn't really apply to them because you're actually going to notice that these vertical lines are kind of weird exceptions to the rules. The y coordinate itself is constantly going to be changing around here, but really the one consistent point in this whole entire line is the fact that the x coordinate is the same for all of them. So because it's the most defining feature of this line, think of it that way, the most defining feature of this line is that the x coordinate is the same throughout, then we simply write it as x is equal to whatever the x coordinate is that it goes through. So as an example, just to kind of practice a little bit, if I were to give you a line like this, like that, like a green line, and it passes through -2, and it's a vertical line like that. So what do I notice here? Well, the x coordinate is constantly equal to -2, so then my equation is just what x is equal to -2. Does that make sense? Hopefully it does. So x is equal to -2 is going to be my equation of that line there. So as I mentioned already, it's a little bit different, a couple new things. So this one actually does not have a y-intercept unless, so one exception, it will not have a y-intercept unless it actually goes straight through the y-axis. So if it goes straight through the y-axis, then technically it has an infinite number of y-intercepts because it actually hits the y-axis the whole entire way through. But that's the only way that it would have a y-intercept. But the main thing here is that the x-intercept, it does have an x-intercept. The x-intercept would simply be whatever the y, whatever value it goes through the whole entire way. So instead of instead of having y-intercept, it actually has an x-intercept. And then there's one last thing that's a little bit odd. And again, I won't test you on this, but especially because you're in pre-IB, it's really good that you do start challenging yourself a bit more and thinking about these tougher questions, right? So the slope of this, it seems a little counterintuitive because it seems like a lot of most lines would have slope. This is actually an exception to the rule. The slope is actually undefined. There is no slope. And the reason for this, and I'm actually going to let you try this out. If you pick any 2 points, doesn't matter which 2 points. Let's say, actually, let's go back to this first example I gave you. Pick this point here in red and pick this point here in purple. If you calculate the rise over run, you're going to end up with some value. So let's say we look at these two here. The rise would be 6, but the run is going to be a little bit odd. The run is actually going to be 0 because you're technically not moving at all in terms of the x coordinate. So when you divide anything by 0, you end up with an infinite answer. So we sometimes say undefined, but a better way to say that is that it's an infinite slope. Basically, think about it this way. This vertical line is moving so fast that you actually cannot measure its speed. So imagine if you were on a line. So obviously, going back to the skiing example, this is pretty steep, right? And this is even steeper. And then you're going to notice that if your slope is so steep, let's say the hill is so steep that it's basically one big straight vertical line all the way through, then you're basically saying it's going so fast that you can't even measure it, right? The change is so incredibly fast, it's infinite. So technically not undefined, just infinite. Again, just so you know, that will definitely not be in the test, okay? But it is really good for you. Obviously, the main thing is for you to identify a vertical line. That will definitely be on the test and the quiz, but I'm not going to ask you about calculating the slope of a vertical line. All right, so now we're talking briefly about, like I said, kind of going over slope and rate of change. So we have talked about slope a lot, and I think everyone's kind of familiar with slope on a graph. But what happens if you're not given a graph? What if you're given 2 points? And some of you already started asking this awesome question. You said, you know, we're not always going to be given a graph. So what do we do if the graph isn't given to you? If the graph is not given to you, or sometimes the graph itself is not going up by the same unit, that also gets a little bit complicated. There's actually luckily a formula that we can use. We talked about the change in y over change in x, but we're essentially kind of piecing it all together now. So the change in y basically measures how far apart, how much the y coordinates have moved by. So if we're calculating how much the y coordinates have moved by, we're essentially just saying, um, you know, what was the change between the y's? So to find the change between the y's, all we're really doing is we're saying if the first coordinate is x1, y1, and the second set of coordinates are x2, y2, we're going to take the two y coordinates right here, and we're simply going to subtract them off. That's all we're doing in this case. So we are going to take the second y coordinate and we're going to subtract off the first y coordinate. And then to find the change in the x, all we're really doing here is simply taking our second x coordinate and we're subtracting off what the first x coordinate was. That's all we're doing there. And again, I hope it kind of makes sense even on this drawing, right? So if you look at the rise right here, we're essentially just saying, all right, if I started off with a y coordinate of y1 and I'm going to a y coordinate of y2, how much did it increase by? Well, going back to a little bit of elementary school, to find a change in a value, you just subtract. So all we're doing is subtracting the second y coordinate from the first y coordinate. And then to find the run, which is going horizontally, we do the exact same thing. We just had to figure out, well, I went from an x coordinate of x1 and from x1, I went to x2. So if I want to figure out how much it has changed by horizontally, which is my run, all I need to do is simply find the difference between them. So I subtract x2 minus x1, and that's going to be my change in x. So this is a nice little formula we can use if you're given any 2 points on the line. So if you're given any 2 points on the line, or even if you're given a graph, sometimes it's a good idea, especially when the graph itself is not going up by 1 the whole entire way through. And there's actually an example from the previous homework about that, where the graph itself was the scale wasn't going up by 1. So because of that, if you tried using rise or run, it wouldn't necessarily work. Rise or run only works if it's going up by 1 the whole way through, right? So in those cases where it doesn't do that, it's definitely a good idea to calculate slope using this formula here. So let's look at an example. So calculate the slope of the line that passes through these points. So we're given the first point 5 and 3 with 7 and -4, and then the next one is 3 and 4 and 7 and 16. All right, so the first one I went a little faster. To find the slope, we're simply going to subtract off the y coordinates. So we take -4 minus 3. And again, consistency is really important. I could go the other way just so, and people always ask, could you go 3 minus -4? Absolutely, nothing wrong with that. But if I decide to go 3 minus -4, I have to do the same for 5 and 7, right? So I tend to always do it this way, where I take the second set of coordinates minus the first set of coordinates. That's the way I like to do it. I'd like to take the second one minus the first one. So -4 minus 3 is going to give me -7. And now I'm going to do the next one. I'm going to have 7 minus 5. So 7 minus 5 gives me 2. And now I piece it all together. -7 divided by 2, it gives me -7 over 2. And I just put the fraction in front. And we talked about this already in the first unit, that you can either leave the negative sign in the numerator, or you can leave it in front of the fraction. Okay. The next example, and I'm actually going to do this in a different way, because I find sometimes the formula, for some reason, tends to throw people off. So I'm going to do it a different way. And again, if you like this more, then use it. And if you don't like this, then ignore me, okay? And if you're watching the video, you can definitely ignore me pretty easily there. So what we're going to do in this case, I like to just put the set of coordinates over top of each other. And then what I do is I simply almost color code this and say, all right, let me find the change in the y first. So let's find the change in the y. So instead of me actually using the formula, you don't have to use the formula. I'm just going to calculate what the change in the y is. So you can do a little bit of mental math here. So I'm going from 4 to 16. So how much did I increase or decrease by, right? Because if I went down, then it would be a decrease. So I went from 4 to 16. That means I went up by 12. And then I'm going to do the exact same thing for the x coordinates. I'm going to find the change in the x. So for the change in x, I'm going to do the exact same thing. I'm going to say, all right, well, I went from 3 to 7. So how much did I go up or down by? Well, in this case, I went up by 4. So then my last step here is to calculate my slope. I'm going to put this all together. Oops, it's supposed to say slope. It's a little messy. My slope will be change in y over change in x. So that means that my change in y is 12 and my change in x is 4. So that means that my total slope is 3. And that's how I can calculate that. So when we are, like I said, you can do it 2 different ways. You can either, write it out like this, kind of put the coordinates over top of each other, calculate the y, change in y, calculate the change in x, and then once you have the change of y, you divide by the change in x, and you're done. Just keep in mind that there's a couple different ways I could have calculated that, right? I forgot to mention this as well. When you are using the formula, it's probably very helpful for you, before you even start, to label your coordinates So I would label it as x1, y1, x2, y2. So some of you might prefer that. And then once you're done, once you've labeled it, then you're simply using the formula, right? All you have to do is sub in the values into the formula. So I'm actually going to do it that way with the formula, step by step. Just showing you two different ways to do it. So if my points are 3 and 4 and 7 and 16, I'm going to simply sub in the values here. So my y2 is 16. My y1, I go back here, is 4. And then I notice that my x2 is 7 and my x1 is 3. Hopefully I didn't mess up when I was saying the points there. And then 16 minus 4 is 12. 7 minus 3 is, is 4. And of course, that ends up giving me 3. So I get the exact same answer. I just did it a slightly different way. So again, find a method that works for you, okay? That makes the most sense. Little warning here, be really careful with the order. We talked about that, right? You can absolutely switch this around. So just so you know, in this last one that we did, it is possible for you to get the slope by doing this. You could have done 4 minus 16, but just keep in mind that if I do 4 minus 16 this way, then I need to be consistent and do 3 minus 7, right? So then it would become 3 minus 7. And then in this case, I mean, you're still going to get the same answer, but it just gets a little bit more complicated because you end up with negatives. You end up with negative 12 divided by negative 4. And it might look like you get a negative answer, but remember, a negative divided by a negative actually gives you a positive. So in the end, you get the same answer either way. So hopefully that's making sense. So really be careful with the order. My suggestion is try to avoid the negatives if you can. That's just my personal preference. I think we've noticed it a couple of times. The negatives definitely complicate our answers. So if you can avoid a negative, avoid it. Okay, collinear points. So if we have 3 points, A, B, C, and this just represents any 3 points, and you want to check if they are collinear, what that means is you're checking to see if the slope of any pair of line segments are equal. So line segments are basically not full lines. They're just kind of like partial lines that connect 2 points. So if you actually look at this example here, I know it's using different letters, P, Q, and R. What I mean by line segments is just the part of the line that connects P to Q. And then another line segment would be Q to R. And then, of course, another line segment would be P all the way up to R, right? So there's kind of 3 different line segments I could look at. So if A and B and C are collinear, that just means that any pair of them, if I calculate the slope between them, I'm going to get the exact same slope. So that means that they have the exact same slope, right? For any pair that I have there. And of course, the word itself might give you a hint as to what this actually means in practice. What it means in practice is that they lie on the same line. And you can actually see here, that's what's happening with P, Q, and R. They all exist on the same line. So because they're all on the same line, that means they have the exact, any pair of points. If I calculate the slope between them, I have the exact same slope. So let's look at an example here. Are the points -8, 0, -6, and 1, and 4 and 6 collinear? So before I even start this question, I'm actually going to show you what this kind of looks like on decimals, just so you have an idea. So I'm going to plot these points out. So I have -8 and 0. Hopefully you didn't see the answer already. -8 and 0, 6 and 1, and I believe, well, you might see it really briefly. It is 4 and 6. And 4 and 6. There we go. So this question is really just asking you, do all these points lie on the same line? So using technology, you could absolutely graph this out, and or using graph paper, you could put these on a graph and then just check yourself. Does it look like they all lie on the same line? Well, your eyes might be deceiving you, right? So don't just look at it and be like, yeah, it looks collinear, right? You actually have to prove that it's collinear. So if you're looking at 3 points and you're not sure if they're collinear or not, you really do have to calculate what the slope is in order to do it, right? You can't just use your eyes to kind of figure out what happens there. So if you want to actually check if they're collinear or not algebraically, like going through all the steps, what you would do is simply calculate the slope between all the different pair of points. So I'm going to first calculate the slope between A and B, then I'm going to calculate the slope between A and C, and then I'm going to calculate the slope between B and C. So I'm going to start with A and B first. So the slope of A to B, just looking at these two here, A to B right there, I'm simply going to take 1 minus 0, and I'm going to skip a couple steps here. So 1 minus 0, which is this, right, which gives us 1. And then I have negative 6 minus negative 8. And be really careful with the calculation here. Negative 6 minus negative 8. When you subtract the negative, you actually add, so you end up with positive 2. So I end up with 1 divided by 2, which is 1/2. So now that I calculated the slope between A and B, I'm going to calculate the slope between A and C. So I'm going to skip a couple steps here, and I'm just going to give you the answer if you're watching this, just so we can kind of get to the end of it. So we have 6 minus 0. 6 minus 0 is 6. And then 4 minus negative 8. 4 plus 8 is 12. And 6 divided by 12 reduces to 1/2. So far, so good. It looks like it's the same slope, but I still have to check for A all the way up to C. So to check the slope between A and C, and I'm going to erase this so it's a little more neat. I'm going to do the exact same thing. I'm going to take 6 minus 0, and then I divide that by 4 minus negative 8. So, oh, sorry, I did this wrong. This is for B and C. I think I just pressed on the wrong one. Let me correct that. I apologize. So I'm going to take the difference between the y coordinates between B and C, and then I find the difference between the x coordinates between B and C. So 6 minus 1 is 5, and then 4 minus negative 6 gives me 10. And 5 divided by 10 is 1/2. So I end up getting 1/2. So because the line segments, the slopes of the line segments are all the same, then you know the 3 points are collinear. And that basically means they all lie on the same line. So going back to that last example here, and I'm kind of cheating a little bit because I already know exactly what the equation is. But hopefully by the end of this lesson, you should also know how to calculate the equation of a line as well. Now, I have to, obviously, there's one extra thing that I know that you may not know, but I know it's going to have a slope of 2x and, sorry, not 2x, 1/2 x. So I know that that's going to be my slope. Now, you could try to visually inspect this yourself. You could try to think to yourself, all right, well, what could the y-intercept be? Well, it could be 1. Nope, doesn't work. 2. Nope, doesn't work. 3. Nope, doesn't work. 4. Yes, it works. So this is actually my equation of the line. Y is equal to 1/2 x plus 4. So you could use technology to kind of help you to verify, right? And I can clearly see that the line goes through all 3 points there. Now, of course, I still want you to, on a test, if I ever do give a question like this on a test or in future classes, make sure you show your work algebraically, right? But it's a great way to use, technology is a great way to verify that it's all correct. Okay, so next point. So now we're getting into determining the equation of a line. So far, we have, like I said, we talked about slope a lot of times. You're probably going to get sick of it, and we're not even done yet. We're going to talk about it even more when we get to other units, right? But so far, what we reviewed so far is that any equation, any line can be determined by this equation here, y is equal to mx plus b. And again, we talked about this. The slope is the m value. It's our m coefficient here. And the b is the constant in the equation, the one that's the number that's by itself. So keep in mind that sometimes, I just want to kind of warn you, in the textbook, they will sometimes switch it around for you. Instead of writing it as y is equal to mx plus b, it is possible to have it in a different order as y is equal to b plus mx. That's why I don't like people to remember it as slope is the first number and b and the y-intercept is the last number. You don't want to remember it that way, right? You want to remember that slope is the coefficient of x and the y-intercept is the constant that's by itself, okay? The number with no variable attached. So how do we calculate the slope? So that's the first thing we're going to talk about. So I know we discussed this already, but I just want to recap all these ideas. So if you're given 2 points on a line, it's quite easy to figure it out. Do rise or run, easy enough. If you're given a table of values, you simply calculate the first differences. So I'm basically just recapping all the ideas that we talked about before. I'm just putting it all in one concise spot here. And then if I have 2 points that are given to you on the line, I simply calculate y2 minus y1 over x2 minus x1. So we have a formula for that. And if you're given an equation, this is probably the easiest thing. all you really have to do is look at the coefficient of x. So we actually saw that in the activity about slope and y-intercept, that instead of us doing all the work to calculate the slope and the first difference and the rate of change, I simply could have looked at the equation that was given to me and identified the coefficient of x, and that would be the slope. So whatever number comes in front of x, that's going to be your m value. Now, keep in mind, that's when we have equations of this form. I don't want to confuse you too much, but coming up soon in Unit 5, we're going to talk about standard form, and then that is a little bit different, right? It's not always going to be the coefficient of x. We have to get it into this form first to see it. Okay, how do you calculate the y-intercept? So the y-intercept also is relatively easy for the most part. So on a graph, all you have to do is figure out where it crosses the y-axis. So the point where it crosses the y-axis, that's your y-intercept. In a table of values, what you're going to do is you're going to be looking for the y-coordinate that matches up or corresponds with x is equal to 0. So wherever the table of values has an x coordinate of equal to 0, you look for the corresponding y value, and that's going to be your y-intercept. And in the equation, it's always going to be the constant value in your equation, so the b value there. And in any other case, if you're only given 2 points, you sometimes will have to use algebra. You're going to actually have to work backwards to figure out what the y-intercept is. This method is a little bit more tricky, and again, I'm going to leave that in Unit 5. So it'll make more sense once we go over how to solve equations. So let's look at an example here. How do you find the equation if you're given a table of values? So to find the equation if you're given a table of values, let's first figure out what the slope is. I will start with that. So the slope is the rate of change, or in this case, because it's a table of values, the difference in y. So what I'm going to do is I'm simply going to calculate how much the y values are increasing or decreasing by. And before I even check, like I said, I think I mentioned this already. Some of you, I know some of you have asked me during study hall and during, when we've kind of interacted about the questions. Am I going to try to trick you with this? Am I going to give you x values that don't all increase by the same amount? I could do that, but just so you know, I'm trying to be a little bit more flexible with this. I'm always going to make sure that the x coordinates increase by the same amount each time. Now, keep in mind, they could increase by, instead of increasing by ones, they could increase by 2, right? And if that's the case, then the first difference, you'll have to divide it by the actual difference in the x. So you would have to take the difference in the y and divide by the difference in the x, right? So it's an extra step there. But generally speaking, because most of the time I'm going to make it so that the x coordinates increase by 1, all you really have to do here is just calculate the first difference. So if the x coordinates are all increasing by 1, just double check that, then this will be quite easy. All you're really doing is finding the first difference. So the first difference is going to be 1 minus 4, which is -3. And then I'm going to find the first difference here. -2 minus 1 is also -3. Then I find the first difference here, -5 minus -2 is -3, right? Because I'm subtracting a negative, which means I'm adding, and of course, -8 minus -5, I subtract a negative, which means I add, so that gives me -3. Okay, so I can clearly see here that my slope is -3 because my first differences are all -3 the whole way through, right? And again, just like I'm going to warn you once more that this is still an easy case because the actual differences between the y-axis is 1 the whole way through, right? If the x's are not all increasing by the same amount, or it's increasing by something different, then you might have to take some extra steps there. But in this case, it's relatively easy. We're just calculating the first differences. The y-intercept is going to be the y coordinate that matches up with x is equal to 0. So what I want to do, I'm actually going to use a highlighter here. I identify this line right here because I can clearly see that at this point, in this row here, the x coordinate is equal to 0. So the y coordinate that matches up with x is equal to 0 is 1. So that means that my y-intercept is going to be 1. So let's piece this all together. My slope is -3. My y-intercept is 1. And that means my equation of the line is y is equal to negative 3x plus 1. So hopefully that makes sense. How do you find the equation if you're given a graph? So if you're given a graph, and I feel like this one you might be a little more familiar with, what you want to do first is identify what the slope is. So to find the slope, you want to pick 2 points that are relatively easy. So I would pick, and this is totally, everyone's going to have a different way to do this. I always think it's a good idea to pick the y-intercept because that will generally be an easy point to pick out. So I can see here that the y-intercept is 0 and negative 1. And let me pick another point that's relatively easy. This one looks like it's easy. It's going to be 1 and 3. So what I mean by easy, you're probably wondering what do I mean by that? I just mean points that are easy to read. You don't want to pick 2 points that are kind of, you don't want to pick like, for example, this point right here. This is technically a point on the line, but in all honesty, I don't even know what the x-coordinate would be. It would be between 2 and 1, sorry, 1 and 2, but in all honesty, it could be 1.7, 1.8, we don't really know, right? So you want to pick points that are actually very, very easy to identify. So ideally, it is right on the corner of the grid, right? So I can clearly see here that 1 and 3 is a very good choice in terms of a point, and so is the y-intercept there. So what I'm going to do next is simply calculate my slope. So I can see here that if I draw a little triangle between them, I can see my rise is 4 and my run is 1. So if my rise is 4 and my run is 1, then that means my slope will be 4 divided by 1, which is 4, right? And that gives me my slope of 4. And my y-intercept here, I already identified it, is negative 1. So it's 0, negative 1, but of course, when we write in the equation, I just write negative 1. I don't have to worry about the 0 when I'm for the y-intercept when I'm subbing it into the equation. So let's piece this all together. My equation is y is equal to 4x minus 1. So keep in mind that the equation does say, and I'm always well aware of this, the equation does say y is equal to mx plus b. But remember, when I add a negative number, I could write plus negative 1 like this. But of course, when you add a negative number, you know that you're just subtracting. So I just simply write it as 4x minus 1. So I hope that kind of makes sense. All right, what if you're given 2 points? So if you're given 2 points, this is a bit trickier. So there is technically ways to do it, but so far you have not learned fully how to do it. But the very least that you can do is find the slope, right? You can at least find the slope if you're given 2 points. And how do we find the slope between 2 points? Use the formula we just learned, y2 minus y1 over x2 minus x1. So we're just going to find the difference in the y and divide by the difference in the x. That's all we're doing there. So it is definitely possible to calculate the slope, but what may not be possible is calculating the y-intercept. So let's do an example here just to see what I mean by this. So if a line passes through 2 and 4 and 5 and 19, what would be the equation of the line? Well, I can tell you one thing, we can definitely find the slope all the time. So to calculate the slope, I'm going to take my difference in the y's and divide by the difference in the x. And I just realized that I know I encourage you to write vertically. I was writing, want to let you know, I'm writing horizontally in this case because unfortunately, for some reason, the format of the slideshow would not allow me to write vertically and it kept skipping lines. So I just put it horizontally here. So going through the steps here, I know I am going to take 19, this y coordinate, subtract off the first y coordinate there. And then I'm going to take the difference between my x coordinates. So I'm going to take this x coordinate here minus the first x coordinate there. So 19 minus 4 is 15. And 5 minus 2 is 3. So then I take 15 divided by 3, and 15 divided by 3 gives me 5. So that's my slope. So once I know my slope, I could work backwards to figure out what my y-intercept is. I also have another choice. I could put this on a graph, and then I could try to figure out what the equation would match up with it based on what I have. So if you're doing this, so I'm going to give you a couple options here. So one way to do this is using technology. So I'm going to show you this. So we have 2 and 4 and 5 and 19. So let me erase this. So again, to write the coordinates, I had to put brackets around it. So 2 and 4 and 5 and 19. And it's kind of looking like this. Sorry, it's hard to see it all there. Okay. So I'd already, like, just looking at these 2 points, right? If I can picture drawing a line going through them, it definitely looks like it's a very steep line, right? You can even just see it. So if I draw a line going through them, it's a little bit off, but you can kind of see it's a pretty steep line there. So what I could do, one option is I could do my best to draw a straight line going through these 2 points, and then I could simply identify where it hits the y-axis. This isn't necessarily going to work though, because it may not be, well, we're human, right? We make errors when we do this, so we may not actually get a perfect line for this. I can do my best with this, but I'm going to tell you right now, it's probably going to be a little off. And I keep getting off with this. And of course, this isn't a perfect tool. So I could try to estimate what the y-intercept is based on where it hits the y-axis there. But again, we're going to be estimating this, right? This is not going to be exact. A different way that you could do this, if you're pretty proficient with technology, you could you could try to write down the equation you have so far. So we know it's going to start with 5x because my slope is 5. And then what you could do is you could kind of play around with the values here. And what's great about decimals is if you don't know what the value is, but you just want to test it out, you can create something called a parameter. A parameter just basically is like a variable that you switch around. So I could add in a slider for b, and basically saying that I don't know what b is, but I'm going to play around with it until I get to that value. So I could try to shift it up, and I'm actually going to notice that it's just moving my line up, which is not really what I want. But if I shift it down, okay, now I'm getting closer and closer and closer. Let's keep going until it hits the line. And it seems like it's going to hit the line right there at -6. And I can just quickly check that it actually went through both points. Yes, it did. So this actually seems to work for both of them. So it seems like my equation would be y is equal to, and I can write this all together, 5x minus 6. So obviously you can use technology to verify this, right? So I showed you 2 different ways to do it. So technology, graphing by hand. Graphing by hand is going to be a bit tough because we're human. We probably will make mistakes. Another way you could do this is using a little bit of algebraic reasoning. So if we actually go back to the very first lesson that we started with in this unit, when we talked about linear patterns, you almost want to picture it this way. If we have the point 2 and 4, you almost want to think of it as if we have a table of values. And actually, I'm going to make a bit more space. So I'm going to draw this over here so I have a little more space. So we have x and we have y. So the point that was given to us was 2 and 4, and then we have 5 and 19 at the bottom here. So you almost want to think to yourself, all right, well, what would happen if I were to count backwards to figure out what the corresponding y-coordinate would be when x is equal to 0. So I could work backwards here. And I know that the slope is 5. So that means that if I want to go backwards in values, I simply take away 5 each time. So if I take away 5, I end up with 14 here. And obviously this is 4. If I take away 5 again, I end up with 9. And then if I take away 5 again, what happens if I take away 5 from 4? I end up at -1. And this is going to be a corresponding, -1 is a corresponding y value when x is equal to 1. So what I can do once again is just go back one step further and just try to figure out what the corresponding y value would be when x is equal to 0. So to go back one step further, I just take away 5 again from the previous y coordinate, and I end up at -6. So that would mean that 0 and -6 is your y-intercept. So because 0 and -6 is your y-intercept, that means that your equation just would simply be 5x minus 6. So that's your final equation there. So keep in mind, there are different alternatives you have here, but just so you know, this will not be on your quiz. or something like this, right? That's more challenging, where I only give you the point. I won't give that to you yet. You will do these kind of questions in units 5 though. So just keep in mind, I'm kind of slightly introducing you to it, okay? So again, we talked about this. You could always work backwards to figure out what the y-intercept is. All right, so just erasing this here. So last little bit here, word problems. So in all the examples that we've done so far, we've been working with graphs, table values. We're looking at points with coordinates. It's relatively easy when I tell you, when you kind of have it in the context of math. What if it's given to you in a different context? So in the word problems, this is where it gets hard, because you don't always know what they're asking you for. So these are just a little bit of hints in terms of keywords you're looking for. So if a question ever talks about finding the rate of change, finding how much you pay per hour, per day, hourly wage, weekly earnings, anything that has to do with a quantity per unit, then you know you're talking about slope. Anything that has to do with speed, how fast or how slow it's moving, it's probably about slope. Anything to do with difference or amount of change and difference, we talked about those two words a lot. You're probably talking about slope, right? And then the y-intercept. So when would you be talking about that? So for the y-intercept, the y-intercept really is, where does the graph start? So anything in the question that talks about a flat fee, if you don't know what that is basically a certain amount that you pay at the beginning, right? For a certain service or whatever it may be. So for example, if you are going to a gym, let's say you're signing up for a gym membership, a flat fee is usually a fee that they charge you at the beginning for like the actual card and for all the like administrative services, right? So it's a fee that everyone has to pay regardless of how long you get the membership for. Another word that you might see that will likely be related to y-intercept is a starting value, or anything that talks about initial value, or anything that talks about beginning, like anything that talks about beginning value, starting value, okay? So again, these questions, the word problems, are not going to be on your test. Are not going to be on your quiz today, but they definitely will come up in the future tasks or tests that we do. So just make sure that you're aware of them. So let's look at an example here. So when she's measuring her heartbeat, Angela notices that there's a linear relationship between people's age and their heart rates. So you can pretty much guess what's happening. So the older you get, the slower your heart rate. So she notices that her heart rate, right now that she's 20, is 138 beats per minute. And her mother's heart rate, who's 45, has a heart rate of 123 beats per minute. And I just realized I forgot to actually write the units. I apologize for that. And I can certainly add that on there. So the question is, what is the slope find the rate of change. Well, it's actually, I kind of told the answer. We're calculating slope, but in this case, it's talking about the rate at which one's heart rate changes based on time. So because we're talking about something to do with rate, I know I'm talking about slope in this case. So this is beats per minute. Just want to make sure I put the units on there. Forgot to add that on. And I believe there's a homework question that was kind of similar to that from before. So the first thing, if you want to calculate the rate at which the heartbeat is changing, you first want to identify what the variables are. So in this case, we're given a word problem. Sometimes it's hard to kind of connect it with the math. Our variables, in this case, we have two variables. We have age, which is independent, and then we have the dependent variable, the y-coordinate, which is going to be our heart rate. So because the age is independent, that's going to be our x-coordinate, and our y-coordinate is going to be the heart rate. So then what I'm going to do is, instead of me actually writing it out as in words, as you know, age of 20 has a 138 beats per minute, I'm actually going to write it out as coordinates. So I'm going to write 20 matched up with 138 beats per minute. And then I'm going to do this in a different color. The 45-year-old, the corresponding beats per minute will be 123. So I simply write them out as coordinates. So once I have the coordinates here, I know exactly what to do with this, right? This looks like normal math. All I have to do is calculate the slope, and I can do rise or run, or y2 minus y1 over x2 minus x1. I'm going to use the formula y2 minus y1 over x2 minus x1. And this ends up giving me 123 minus 138. So I take 123, I subtract off 138, and of course I have to be consistent. Since I started with 123 minus 138, so the second point, so the second age minus the first age, I have to do the same for the x coordinates. I'm going to take 45 minus 20, and 45 minus 20 gives me 25, and then I end up with negative 15 over 25. And this technically reduces to a fraction, which is negative 2 over 5. But because we're talking about beats per minute, and we're talking about a quantity that we probably want to measure a little, oh, actually not 2 over 5, 3 over 5, sorry. Because we're talking about a quantity that we normally want to measure a little bit quicker, in real life, we most likely would prefer a decimal. So we leave it as negative 0.6. And there's the homework, and that's it for now, okay? So again, make sure that you review for your quiz, and keep in mind some of the homework questions may not show up on the quiz, because the quiz will be relatively easy, but they will show up in later assessments, okay? Best of luck.